Validity and reliability of standardized tests. Test validity. Validity is an essential requirement for any measurement procedures. It is especially important in high-stakes tests, such as the standardized test. Validity means that the instrument or the test measures what it was exactly designed to measure. Internal validity is where the changes and/or effects resulting from introducing a particular variable are caused by that variable, not by any other variables. Internal validity could be achieved by controlling external and contaminating variables that introduce undesirable and unintended effects. An example of this variable is a new teaching method. External validity, also known as generalizability, refers to the degree to which results can be generalized beyond the scope of the sample that went through the research experiences. We can achieve external validity through randomization and controlling of external variables. This type of validity is particularly important to tests that are designed to seek generalized results from samples to the population. Content validity refers to the degree to which test items adequately represent the content it was designed to measure. This does not mean that a single test would reflect every single element of the content. Test developers who seek to check the extent to which students master the taught content or achieve the objectives of a taught course, content validity, can use one of the two methods: content experts or jury members, and table of specifications. Content experts or jury members. Content experts, subject matter experts, or jury members check instrument validity by first making sure that the test developer has spelled out the themes of the content in light of the test objectives, allocated each theme of content a specific weight, represented each theme of content according to the allocated weight, determined levels of thinking or objectives, determined weights to levels of thinking, objectives percentages, distributed the items each theme of content according to the levels of thinking weights. Table of specifications. The table of specifications method helps content experts or jury members to determine in scientific and systematic ways the specifications of test contents in terms of percentages of content to be represented on the test and the objective levels each part of the content addresses. Developing the table of specifications involves 5 steps. Determine the test content, determine the relative weight of content, determine the relative weight of objectives, determine items among themes of content, determine items among levels of objectives. Construct validity is the extent to which an instrument clearly and adequately shows that it measures the operational aspects of the construct it sought to measure. To assess a construct, test developers need to provide an operational definition of the concept. For example, if they seek to assess creativity, they need to precisely spell out what is meant by creativity. In this example, creativity could be operationally defined as the ability to A. Produce new ideas, B. Produce original ideas, C. Look at existing things in different ways, and D. Use existing things in different ways. Criterion validity comprises of many validity types, which all involves the administration of 2 instruments. The first instrument, also known as the criterion, has to be an established instrument. The second instrument is the new instrument that test developers seek to establish its validity. Predictive validity involves the administration of a new instrument that makes predictions about a certain phenomenon at a specific point of time, and running another valid instrument, criterion, at a later specific point of time. Concurrent validity is the degree to which individual scores on a new test correspond to their scores on an established test of the same construct that is administered shortly before or after the new test. For example, a group of students took a new test that measured creativity. A week or month later, before or after, the same students took another valid criterion test that also measures creativity. Both tests define creativity in similar operational terms. If the results gained from the two tests correlated high, this provides evidence that the new test shows concurrent validity. Convergent validity involves a simultaneous collection of data about a certain phenomenon using two or more instruments. Each instrument is supposed to be valid, where each instrument stands as a criterion for each other. If the instrument yields similar data, this indicates convergent validity. This means that the data from each instrument converged. In contrast, concurrent validity involves an established or valid instrument and the new instrument that is under validation. Both concurrent and convergent validity involves the administration of instruments shortly before or after one another. An example of convergent validity involves gathering data about student creativity through observations, interviews, and tests. If the data converges through high correlations from the three instruments, this provides evidence of convergent validity. Convergent validity is more or less like methodological triangular, wherein researchers gather data about the same phenomenon through two or more methods. Test reliability. Reliability refers to how much measurement error is present in the scores yielded by the test. Reliability is the extent to which tests or instrument scores are free of measurement errors, that an instrument provides consistent results when completed by the same or similar samples on different occasions. There are several methods to determine the reliability of the test. Each method addresses a particular type of reliability. The three types of reliability are 1. Reliability as stability, test, retest, pre, post-test. 2. Reliability as equivalence, alternate equivalent forms. And 3. Reliability as internal consistency. Reliability as stability, test, retest, pre, post-test. This method seeks to measure the stability of scores over time. When one instrument is carried out on a group on one occasion and is administered again on the same or similar group on another occasion, it should give similar results. Reliability as equivalence, alternate forms, inter-rater. There are two methods of reliability as equivalence: equivalent alternate forms reliability or inter-rater reliability. The equivalent or alternate forms reliability involves developing two versions of one instrument to measure the same content. Alternate forms reliability could be also over time, diachronic, and over sample, synchronic. Test developers can undertake the alternate forms method diachronically over time by administering the first form to a particular sample for pre-testing and the second equivalent form to the same sample for post-testing. The two alternate forms are administered on two different occasions for one sample. The inter-rater reliability involves reaching agreement between two or more raters with regard to data collected through grids of observations or structured interviews. The raters have to observe the same event or collect the same data, and that they all enter them into the same categories. Reliability as internal consistency. Reliability as internal consistency means that respondents' performance on all test items remain consistent. This means that the respondent's performance does not improve on some sections rather than the others. reliability as internal consistency is appropriate for homogeneous tests which do not have different sets of content. The end.